The CHIC project was aimed to see how genome editing could be of benefit to consumers in a small crop. And for that we choose chicory, which is a relatively small crop, and with small I mean grown on a little areas. The CHIC project will benefit, I think, already the whole value chain of chicory, from the farmer until the consumer, potentially. But again, chicory is quite a minor crop, minor in the sense that the area where it is grown is not so large, and also the market is not so big. But I think it is a kind of an example how you could implement such a project also in other crops, also in larger crops which are grown on a worldwide scale. Mm-hmm. So in that sense, indirectly, the CHIC project will also influence other parts of the world and other crops.
I think, of course, there's been lots of nice leads in terms of bioactive molecules, which could be useful in the medical field. That would be a direct advantage to the consumer. For the farmers, of course, we have some very nice results on breeding applications. So we've been using genome editing to actually make breeding in chicory more easy. And of course, if that's possible, then you can speed up the entire method of breeding. And that, for the farmer, that gives them varieties much quicker, and perhaps varieties with more interesting characteristics for them in the field.
We show that you can use these new plant breeding techniques in order to improve a crop like chicory for the production of more health beneficial inulin, in my case.
There are several possibilities. One is that for the, let's say, the most direct benefit would be for the industry, the existing industry using chicory as a product. So for the extraction of inulin, which is the main product, the varieties that have been developed by new plant breeding technologies can lead to reduced energy consumption for the production of inulin, so that's an environmental benefit, but also, of course, reduced costs for the companies that exploit chicory, and that way to make the processes more efficient and more, with more benefits. And the other, I would say, one other potential benefit of the project is more long-term, is the development of new products. So those, based on those, for example, those sesquiterpene lactones, where new varieties can be brought to the market for specific applications, essentially in the area of human health.
Yeah, what we have seen from our assessment is that the small or the development in the CHIC project also unfolds in the global economy, so there can be benefits to farmers, and as well as mentioned earlier before, that the greenhouse gas emissions can be reduced, the farmers' income could be improved or something like that. So there are, over the whole society, over the whole economy or the environment, benefits can be created.
But also for cheaper production, more yield of inulin. So this is also good for the farmer, it's good for the industry.
When it comes to genome editing and genome edited plants, I think that CHIC project really could contribute to increasing the know-how and also the consumer and stakeholder point of views, how it is perceived and what might be the future of the genome editing. And then on the other hand, as myself, I'm really excited about the bioactivity potential of the chicory terpenes, and there were a lot of very interesting results obtained. So for example, this global threat of antibiotic resistance that we are facing in the world, so that we could see that this kind of waste stream of the industrial crop could potentially contribute to fighting against the antibiotic resistant bacteria also. So I think that those are something that we couldn't see in beforehand, and now we saw quite interesting results.
Furthermore, we have provided a very comprehensive overview on the regulatory and legislation landscape in Europe and in the world, from which political parties and other stakeholder groups can benefit as they find everything condensed in one report or publication, and have a good comparison and idea of how the regulatory regimes are changing over time, as we have kept it updated during the runtime of the project to see the development on technical sides and also on the regulation side.
Societal benefit, I must say. And of course, the whole goal of this project was to show also for policymakers that using these new plant breeding techniques really can be beneficial, because it's fast, it's really targeted, and that's for Europe important, but also the goals that we reached are also important outside Europe.
The benefit that we are producing here, if we succeed in communicating it, is that we have an example of how we can use a stakeholder engagement structure and that follows the principles of responsible research and innovation to a degree that allows for a reasonable steering of such a large project, even in a politically contested area.
I mean, really helps the EU community in better knowledge about these techniques. So, and that is what I really loved about this project as well. Not only the focus on the science, but also the focus on the communication. And not a directive communication, look, this is what we scientists can do and this is how you should implement it, but really a dialogue. If we can do this, what would you think then? Would you like it? Would you, and what are your objections?